Okay, Algebra 2 skills number 23, simplifying rational expressions. So let's talk about what a rational expression is. Rational expression is just a polynomial divided by another polynomial. So we talked in the past about what a polynomial was. Remember, the word rational means like a ratio in math. So you can see it's a ratio or a division of two polynomials. So the first example, this is a very typical rational expression. I do want to express that one thing you cannot do is cross off these x squareds because of the plus and the minus. Anything that's being added or subtracted together kind of binds that together, and you can't take away part of that that's attached by plus or minus without taking the whole thing. So that's the first mistake to avoid, is to think that you can take those off or that you can reduce anything here. If it's attached with a plus or a minus, don't mess with it. Instead, what we want to do is factor. And these are very conventional factoring. The factors of negative 20 that add to 8 are positive 10 and negative 2, and so forth on the bottom. And you'll notice that we have this common factor of x minus 2. Now, the x minus 2 I put in red because we can cancel that. The reason we can cancel it is we have a separation right here and right here with multiplication symbols. So remember, before, we can't cross off the x squareds because they're separated by plus or minus. But if we're separated with a multiplication symbol, we can cross them out. The x and 2 are bound together with a minus, but I'm taking the whole thing out. So I end up with x plus 10 and then x over x minus 11. And on the answer there, we don't need parentheses anymore because we only have one factor per level, and we can't cross the x's off. So this will be correct for the first example. The second example is a little bit different, a little more less conventional. So I'm going to do it two different ways. One way you can see this is by factoring out an x squared on top. For a GCF, I didn't color code this, but notice we have an x, actually two x's out here, and then we have this x, which again is separated with multiplication. That's the key. This x and 6 are stuck together. They can only go if they both go at the same time. But this x is free to go along with both of those x's. So what I did here was take away one of those two x's to make one, and I took away that x to compensate for it. So this is one presentation of the answer. Of course, you could distribute that x back in if you want to. Another way of thinking about this is if you have a single denominator and you're adding or subtracting on top, you can write two different fractions if you wanted to, and then just simplify the two fractions independently. So this single denominator became two denominators as long as I separate the top. And now I have three independent x's. I can take away one of those three to make it x squared. To compensate, I took that x away. And here I had two x's, so I took away one of those, and I compensated by taking away the bottom. Notice also that we made 6/4 3/2. It's a simple fraction reduction. So these two answers are equivalent. They don't look alike, but they are the same. If you were to doctor this up, you can make it look like that. And we could work on this to make it look like that. They are the same answer. So simplifying rational expressions.